right, today we're going to look at the second part of section 6.7. In the first half, we looked at operations with functions, so adding, subtracting, multiplying, and dividing them. Today we're going to look at something called the composition of two functions. So a composition of function is an idea of putting a function inside another function. All right, like inception, but with functions instead of dreams. So our hint today, start on the inside and work your way out when composing functions. To get started, let's consider function f being 3x plus 1 and function g being x squared plus 2. The first thing to notice is this notation. When you see this little open circle here, it means you're doing a composition. It is different from multiplication. Multiplication has a little solid dot. This is an open circle. All right, and this tells me we're doing a composition f of g of 2. Now, I want you to get in the habit of rewriting it like the second notation. These are equivalent, but the second one is going to be a little clearer in terms of what we're supposed to do. So it's telling us to find g of 2 and then take that answer and plug it into function f. Okay, so looking at our first given functions here. G is x squared plus 2. So if we find g of 2, we're taking this x squared plus 2 and we're substituting a 2 in place of our x. Okay? Well, 2 squared is 4 and 4 plus 2 would give us a 6. So g of 2 is 6. And now it's telling me find f of 6. So we're going to plug that answer into the other function, and that function was 3 times x plus 1, and in place of our x, we're going to put in our 6. 3 times 6 is 18, plus 1, we would say f of g of 2 gives us 19. Okay, notice on the second one here that we're doing the reverse, g of f of 2. So this time we want to find f of 2 first. So we're starting with function f, which was 3 times our x value plus 1, and we are substituting in a 2. So we end up with 6 plus 1, which would be 7. So f of 2 equals 7. Now we want to find g of that. So g of 7, we go to our g function, which is something squared plus 2, and we're going to dump that answer in. That's 7. 7 squared is 49, plus 2 is 51. So g of 7 is 51. All right, and I'm going to actually rewrite this. Let's say g of f of 2 is 51. Okay? All right, let's try another one. This time f of x equals the square root of x plus 3, and g of x equals x divided by 2. Okay, so they're saying find f of g of 12. Again, I want you to get in the habit of rewriting this. It's f of g of 12. Okay, so we need to plug a 12 into the g function first. So let's find g of 12. The function is x divided by 2, so 12 divided by 2 is 6. And now we're going to plug 6 into function f, the square root of something plus 3. We're plugging in a 6. So we have the square root of 9, which is 3. So we would say f of g, I'm running out of space here. So f of g of 12 gives us 3. All right, go ahead and pause the recording and try this one, and then turn it back on when you are ready. Okay, rewriting it, we know this is equivalent to g of f of 1. So we're going to find f of 1 first. Function f is the square root of x plus 3, and we're plugging in a 1. So 1 plus 3 is 4, square rooted gets us a 2. Then we're going to take that answer and plug it into g. So putting a 2 into g, we have x, which is 2, divided by 2, and we get a 1. So g of f of 1 is 1. So in all of the examples we've done so far, we've had a value that we've been given to start with. In other words, they said find f of g of 1 or g of f of 1, f of g of 12. They've given me a starting number to plug in for x. We can do compositions that are more generic, where we just have an x still in the problem. It says the composition of function g with function f, written like this, again with that open circle, it's defined as this. The domain of our composition consists of the x values in the domain of f, for which f of x is then in the domain of g. Okay? So we're going to evaluate f of x first, then use that as our input to g. And that's what we've been doing on these first 4 examples. But we can also do this where we have just an equation or an expression to substitute in as well. I do want you to highlight this last little sentence here. Function composition is not commutative. F of g of x does not always equal g of f of x. So if we change the order of that composition, we can get different answers out. All right, to compose 2 functions together, simply plug an entire inner function wherever we see an x in the outer function. All right, don't forget it's usually easier when we rewrite the notation. So we're going to start out with the function f being negative 2x plus 3 and function g being x plus 2. This one is saying find g of f of x. Okay, so again, we have this unknown number here, just this x that we're supposed to plug in. So this is telling me to take function f of x, and dump it into function g. Okay, so I'm going to start with function g. Function g says something minus 2, okay, x minus 2. But in place of that x, we are going to dump function f. And then we just have to simplify it as far as we can go. So this is equivalent to negative 2x plus 3 minus a 2. Combining like terms, we get negative 2x plus 1. Now, if you are asked for domain, there were no domain restrictions on function f. Domain is all reals, and same with function g. So when I do my composition, there's nothing I have to worry about. I look at my final answer here for g of f of x. There's no square roots, no denominators. My domain would be all reals. Okay, let's look at the reverse order. This time it's saying to take f of g of x. So now we're plugging g of x inside function f. So I'm going to write out function f, which is negative 2 times something plus 3, and I'm going to substitute in function g. I'm going to put this one inside where the x was. Now I do have a little distributing I can do to clean this up. So negative 2x plus 4 plus 3 gives us negative 2x plus 7. Excuse me. And notice that these two answers are not the same. G of f is not the same as f of g. Okay? Again, our domain here would be all real numbers. All right, let's change our functions. This time we want function f to be 2x plus 1 and function g to be x squared minus 1. Again, no domain restrictions. We don't have any denominators or any square roots. So we're starting out with g of f of x. So we start with function g, which is something squared minus 1. And this is telling me that I want to dump f of x inside of g. So I'm going to plug f of x into that g function. Now be careful here, we're squaring this quantity, so we really have to think of having 2 of these. We have to FOIL that out. 2x times 2x would be 4x squared. Outsides we get 2x. Insides we also get 2x. Last we get a 1. And then don't forget that little negative 1 that was on the outside of that expression. And now combining like terms, we have g of f of x is 4x squared plus 4x. Those 1's are going to cancel out. All right. Why don't you pause the video and try to do this next one on your own, and then turn it back on when you're ready. All right. So we are finding f of g of x. So we're going to start with function f. Function f was 2 times something plus 1. And we are dumping function g inside of that. So we're putting x squared minus 1 inside of function f. Distributing our 2, we get 2x squared minus 2 plus that outside 1. So f of g is 2x squared minus 1. Again, we are getting different answers doing these in the reverse order. All right, our next example. We have f of x equals 2x plus 3 and g of x equals x minus 5 divided by 2. Now I do see a fraction here, but I don't have any variable in the denominator. So again, my domain for these would be all reals. All right, so let's start with g of f of x. Again, we're starting with function g, which is something minus 5 divided by a 2. And this is telling me that I want to put f of x inside of function g. So I'm putting this f of x inside of function g where the x was. Okay, now I need to simplify. The numerator here, we end up with 2x plus 3 minus a 5. So we have 2x minus 2. And then I could simplify this and divide a 2 out of everything. So I get g of f of x equals just x minus 1. 2x divided by 2 is 1x, and negative 2 divided by 2 is negative 1. Okay, trying the reverse order. This time we're doing f of g. So we're starting with function f, 2 times something plus 3, and we're plugging g into it. So we're putting x minus 5 divided by 2 inside. And now to simplify this, notice those 2's drop out. So we have f of g of x. Our 2's drop out, we get x minus 5 plus 3. So we multiplied by 2 and we divided by 2. Those cancel each other out. Simplifying, f of g of x is simply x minus 2. All right, we're going to try one word problem that involves compositions. It says you have a coupon good for $5 off the price of any large pizza. You also get an additional 10% discount on any pizza if you show your student ID. How much more would you pay for a large pizza if the cashier applies the coupon first? Okay, now we've talked about the order of compositions mattering. So f of g and g of f do not get us the same thing. So when we combine, do a composition of the coupon and the discount, the order we do them in is going to affect our answer. So let's find function c and function d. C is going to be our coupon, and d will be our discount. Okay, so c of x, the coupon, it says, is good for $5 off. So if we let x equal the price of our pizza, the coupon is just saying we're going to take our x amount and take off $5. The discount says we're going to take our x and subtract 10% of it. So we're subtracting 0.10 of our x price. Well, 1x minus a tenth of an x gives us 9/10 of an x, or 90% is what we would have to pay since we're taking 10% off. All right, so the next step says now compose the functions to apply the discount and then the coupon. So we're going to take our X price, we're going to apply the discount, and then we're going to apply the coupon. Okay? And we'll come back to that in a second. Step 3 says to compose the function, so we apply the coupon first. So now we're going to do a coupon on our initial price, and then apply the discount after. Okay, so we're doing these in 2 different orders. So this first one, we do the coupon of the discount of X. So C of D means we start with function C, which is something minus 5, and we dump our discount equation into it. And there's really nothing to do to simplify that. We can get rid of the parentheses. We're just going to have 90% of our initial price minus the $5. For the second one, it says start with function D, which was 0.9x, and we're putting C into it, so we're putting x minus 5 inside there. And if we distribute, we get 0.9x minus 0.9 times 5 would be 4.5. Subtract the functions to see how much more you would pay. So what is the difference? The initial one was 0.9x minus 5. If we subtract the second version here, 0.9x minus 4.5, the 0.9x's are going to drop out. We have negative 5 minus a negative 4.5, or plus. Adding those up, we get negative 0.5. Okay, so it's 50 cents more doing the coupon first and then the discount. All right, let me know if you have any questions.